In this session, we're going to be talking about what kind of use cases, what kind of actual network functions are going to be addressed or are already addressed with the network cloud, and in a way, what kind of challenges is this solving, or what kind of actual problems in the network is this resolving network cloud. So this is chapter 2 of our session, and here we go into it. What we are looking at here is that same network topology that we've seen before on a traditional model, only this is how it will look like with a network cloud. I think the title word here is flexibility. Any type of a network function can run in any location of the network and on any given size. And when we're looking into the specifics of this, I'm not sure if you can see all the small icons here in between, but this is the thing that matters the most. Looking at this big cluster here in kind of the middle of the screen, you see a P/LSR function. That's a core router which is running as a service on this cluster, on this pod, and it's running with all of its allocated resources, whatever that core function needs within the attributes or the resources of this cluster is being provided to this service. But within that same location, we will also have a PE router, and a PE router will have a different set of requirements from the cluster, and it can coexist on that same cluster because, well, they are co-located. So why not also co-share them on the same infrastructure? Obviously, you could have a peering device, which is again connecting that network to a peering network, and this peering device can be somewhere as a standalone. It can be co-located alongside an aggregation site, and it can be co-located alongside your core site, and you can just mount these functions onto that same infrastructure and obviously expand your use cases from just a single use case which is being served by a single machine into multiple use cases which are being served by a cluster of machines, just like a cloud, right? So you can expand this all the way up to the core and even in towards the connectivity to the cloud with a DCI function, data center interconnect, and you can take it all the way down to the access with catering for 5G type of backhauling with front haul gateway and the backhaul gateway. Those are the type of boxes which I mentioned earlier on, is something which is soon coming. So this is what we see as a solution portfolio. Obviously, we have one product on the shelf. It's called the Network Cloud. What it's providing is a multi-service platform that spans end-to-end within the network and can cater any type of a network function to be mounted onto this cluster. And with that, it doesn't have to be network functions which are developed here in-house in DriveNets. It can also be a third party, like the example here is given. An analytics function that can run on top of a cluster can serve that same level of capabilities and be mounted on an infrastructure which is already in place. So moving further, we are now looking at the different network locations of the cloud as something which is more reflective of the size. Here you can see the 1.8 terabit per second box, which is kind of more on the future aspect of things, but it's here in terms of a potential standalone machine. And then when you need a small or a medium cluster, this is roughly the capacity that you will go towards moving into a large cluster or an extra large cluster. And like I said, any size in between is valid, and it can also grow with how you're scaling the network. The interesting part is that operating all of this is the same way. Managing a single box using our orchestration system and managing a cluster of 10 boxes or 50 boxes or hundreds of boxes is essentially the same level of complexity. Orchestrating the whole thing from a single pane of glass, the same way as cloud is being orchestrated, simplifies and kind of pushes aside the question of how many boxes are you managing in your network, because all of this cluster is being reflected to the outside world, again, as a single entity. Now, when you have this cluster of dedicated standalone boxes, the failure domain of this cluster is also shrunk to the level of a single box. And once a single box is failing, it's a single box which is failing. It's not that the whole router or the whole network appliance is failing, but only one element of it. And of course, there is a high level of resiliency built into these architectures to begin with, so we can cover up essentially every single failure which happens, every type of failure that can happen, even without impacting traffic. And when it comes to admitting maintenance into the network or taking a maintenance window and triggering the network into some sort of an upgrade, then once again, we can carve out a portion of the cluster, upgrade it as a standalone, and pull it back in. The window is shut. We don't need a maintenance window, or we can keep it to something which is very, very minimal as opposed to existing traditional models that exist today. So that's the operational aspect. And when I was talking about how do we reduce OpEx, this is how we reduce OpEx. This is how operating this kind of a network is much more cost effective, again, cloud-like, much more cost effective than operating a traditional network. That's on the physical side of things. Now, when we're looking into different network services or different routing functions in this example, which are running on top of the infrastructure, let's look as an example of how routers traditionally are being built. A router is a monolith. It's a monolith on the hardware side, and it's also a monolith on the software side. So you have one software, one code running a single function. That's one monolith. And then the chassis, as we noted, is one enclosure. The thing is that this chassis or this software was built to serve a specific routing function. And it's the same chassis and software which will eventually purpose a different type of network function that they cannot coexist, right? So when you're building this in the traditional way and looking at a specific use case, such as co-routing, which is reflected here with this black diamond, the core function is mainly consuming resources which are bandwidth worthy, not very heavy on the CPU resources, not very heavy on the TCAM resources, not very heavy on the quality of service attributes. But when you're building a router, you're having all of these elements in place, right? So when you're taking a router and you're utilizing it to serve a core or purposing it to serve a core function, all of these other attributes or resources are wasted. Same way if you would be establishing an edge router, more BGP sessions, therefore more heavier on the compute cycles which are being consumed, more TCAM entries, but less bandwidth, right? Or less quality of service resources allocated to this use case. So different use cases have a different set of resources which they need to consume. When your monolith router serves a single application, then by definition, it's wasting all of the other resources, and these cannot be reallocated. This is the same as taking a server, which is running a specific application, and when this application is not using the heavy memory which is placed in that server, then that's wasted memory. Or when the CPU is idle, that's wasted CPU. Same way as it's been solved by cloud for servers, this is how network cloud is solving this for networks. So I'll take it into an actual example and looking here at 4 types of routers: a PE router, a peering router, an aggregation router, and a core router. Even if these boxes have been built by the same vendor and it's being purposed for various use cases, eventually they are being deployed into one use case. What you see here is on the colored interfaces, these are the resources which are being consumed, and the darker ones are resources which are not being consumed. Now, we were just using this as kind of an image to reflect the point that not all resources are being consumed. We're just using ports because we cannot give you a picture of a TCAM. It's not visual enough. But in a way, a lot of resources within each and every one of these applications, different use cases, is kind of shining away from one of these allocated resources. So it could be that your aggregation router cannot reach its peak potential, but not because of the ports, but because you ran out of CPU cycles. And you don't even know that this is your limiting factor, or you ran out of TCAM entries, and you don't even understand that this is your limiting factor. That's the type of limitation that that enclosure throws up on the establishment of your network. As opposed to this, we have one unified infrastructure, one unified pod. Again, a class, factory topology, lots of elements connected, and all of these resources, each and every one of these sub-elements, the NCP, which I mentioned before, the NCF or the NCC, the standalone server x86, off the shelf, all of them are reflecting resources. They have a CPU, they have an ASIC, and this is all a pool, a single pool of resources. And once you have applications running on top, then the allocation of these resources is reflective to what kind of use case or what kind of attributes does this use case mandate, right? Jumping through an example, and I suppose that we have all been waiting for this example with a nice picture of an AT&T building. This is what we've been doing with AT&T. The announcement came from AT&T a few months back. It's not a winning announcement by AT&T. It's an actual deployment announcement, meaning that we are already running within the AT&T core network. So this is not just a side corner of the network where they are doing experiments. This is the actual core of AT&T, spanning coast to coast across the United States of America. The largest core in America is now run by a disaggregated model provided by DriveNets. And what does it actually mean? Other than the fact that it's very exciting and we're very happy and we are very grateful for AT&T for allowing us this opportunity to excel within their network. But it also means that we passed all the certificates that AT&T imposed or are imposing on any device before they admit it into their network. So whenever it comes to carrier grade of the solution, be it the reliability of the boxes as standalone boxes, like I said, it's not coming from us, but it's still boxes that needs to be admitted into a network. In the level of reliability of the software, I wouldn't say it's bug-free, but it's rock solid to be fit into, again, the largest core in America. Resiliency of the complete solution, how we deal with failure, security aspects which are attributed on top of the cluster, the scalability, which I mentioned already several times, from small to large and in any location. And of course, the overall operational aspect, how easy it is to operate this kind of a network, how easy it is to manage this kind of a network is something which is being built inherently by the way that we architected it, but AT&T is kind of the indication, proof point, field proof that it's a solid solution. We are happy to talk about AT&T because it's the one customer that we have, which is public, but there are others, which we cannot really discuss, but it's nice to see a nice AT&T building within our slide deck. So much for use cases. On a general level, any type of a network function can run on a network cloud. But what's the problem that we are trying to solve? What was stopping networks, or what was preventing service providers to go into that direction? And why will they go into that direction now? What we see on the left-hand side, this graph is showing the decline of profitability that service providers are facing. It's a challenge. And why is this a challenge? The way that we consume network is by the fact that bandwidth is free for ourselves as users, right? Same fee that I'm paying to my service provider today has been the one which I was paying 10 years ago, but the amount of bandwidth that I'm getting is perhaps 1,000 times higher. So bandwidth is in a way for free because it's not value. It's just bandwidth, right? Now, building new networks or throwing in more bandwidth into the network is becoming cheaper from generation to generation, right? The cost per bit is indeed lowering with traditional models. It's just that it's not lowering fast enough. What happens in parallel to this is that the revenue per bit is also shrinking. Now, where is the money going? Because I'm paying more for communication today than I did 5 years ago. It's just that I'm paying Spotify and Netflix, but I'm not paying my local service provider. These over-the-top services are eating a lot of the revenue while the service provider is laying down the infrastructure. That's what happens. Now, when these two lines meet, what you see on this graph, it's the point where it stops being financially justified to deploy new networks. Now, this is not an exact axis of time, but we are not far from that point. And obviously, every service provider is in a different place within this graph, but they are all headed in the same direction of the fact that deploying a new network or introducing more bandwidth into their infrastructure just doesn't make any financial sense anymore. And that's a very, very big problem. What DriveNets is doing is introducing or bringing transformation into this clogged industry. Transformation is something that service providers have been trying to push into the networks for, I say, 10 to 15 years. It came in different names. It came in the name of VNFs or CNF. There are lots of variants to this, and this is definitely something that service providers are targeting, right? And what Network Cloud is exactly implementing or satisfying for this capability, basically because it decouples the growth of the network from the growth of the service provider or from the growth of his potential revenue. How this is translated eventually to revenue growth is something that we will see two slides down the line. The next item here is something that I call the pay-as-you-grow myth of the chassis. What happens is that the network has its life cycle, typically 5 years. And then the chassis as well, the product has its life cycle likewise. I'm not sure if it's also 5 years, but it's definitely different or not exactly aligned to the life cycle of the network. So these two do not move as two aligned entities. And wherever there is misalignment, you reach a situation where the chassis that you started it, kind of a starting small pay-as-you-grow approach, and with only chassis which is only partially filled, is not satisfying the ongoing needs of the network. And when new hardware is being introduced into this existing chassis, the chassis is not always there to cater for the new line card. So when new line cards are coming, new ASICs are coming, you should be happy, right? So you have more throughput that you can push into a single element. But then when you plug in this new card, one option is that the chassis is limiting you because the overall power feed into this slot is not sufficient to cater for the new line card because new hardware, more capacity takes more power. That's one aspect. Otherwise, other limitations on the chassis are what's blocking you. So the amount of clock cycles, CPU cycles, which are available within the chassis is what's stopping the application from continuously growing and not the number of ports. So the pay-as-you-grow aspect, the approach is not really fit or meeting the potential or living up to its potential expectation or the expected outcome that the service provider had in mind. Still, they're putting something in place, and then 3 years down the line, when they need to do the upgrade, they end up doing a forklift. And because you cannot really scale up a chassis, you just throw it out and you put a new one instead. In this case, when we're talking about a forklift, you actually need a forklift because these things weigh half a ton. This is the kind of dilemma that we're facing, or service providers are facing. This curve here is talking about another dilemma that service providers are facing, and this is where innovation comes into play. It's called a first cost curve. It's reflective of from the very point of a new service which is being incepted and how it's being developed over time into the point where it's being launched, typically as a pilot. After some pilot period, you go into live production and span the service, run this service for a while until you get to the point of the first profit that you're making. So all of your investment is then compensated. What happens is that planning towards something like that is very cumbersome. There is a lot of money that needs to be invested upfront, both in the case of deploying new hardware, which is supporting the new service, obviously. And you need to take this to your CFO and convince him that this service is worthwhile. So any service which is not really a big splash of revenue or potential revenue increase is just going to be tossed aside. And most services actually die out like this. They don't even reach the market. What DriveNets is introducing is a hardware agnostic service introduction. Once the infrastructure is in place, this platform called Network Cloud is in place, launching a new service becomes something which is trivial. It's software based. Triggering new software is as easy as it is by running it in cloud. The investment to be put in place has already been done because the hardware is already there, and the hardware is agnostic to what kind of application is running up top. So just develop your application and shoot it out. First off, shoot it out in a pilot, choose which locations in the network you want this to be positioned at, right? And once you understand that it's successful, expand it to your entire network. How long does it take? A click of a button. What you see here is a snapshot from our DNOR and kind of the application multi-service marketplace that DNOR is granting its users. Just take an application, shoot it into your network, just kind of a drag and drop, literally drag and drop an application onto your cluster and shoot it out, launch it into your network. So bringing it back to the three pillars of what does it mean to build a network like cloud, and looking at these attributes, an open, standard, white box with a complete ecosystem translates to lower cost and better scaling of your network. Virtualization of the hardware translates to lower cost and better scaling of the network. The containerized software translates to, again, cost scaling, and also introduces innovation, because now innovation becomes software-based. Running any service on any port within the cluster. That level of flexibility, again, drives better utilization, allows better scaling, both of the service and of the infrastructure. And again, launching new services into the network in a very fast manner. So just kind of to wrap this up, when we're looking at network cloud, and this is something perhaps that we learned from our customers, you don't go out full blown and shoot everything and take your entire network, toss it out. That's not how it works. Hopefully it is, but that's not how it works. Typically what happens is that there is one use case which meets the timeline of its refresh cycle. Let's say this is a core, okay? Or let's say this is the aggregation network that needs a refresh. So you start out your network cloud from that location. Your next network upgrade, or from that establishment, from this foundation of network cloud, you can then grow the infrastructure. And you can grow the infrastructure in three directions. You can grow in size, so starting with a small cluster and just growing it to whatever capacity that you need. You can grow in location, so you can start with your aggregation location of the network and kind of shift more towards the access, or more towards the subscribers, or even higher up towards the core. In terms of location, any direction is valid. And of course, in terms of function, and perhaps this is the most interesting aspect, you can start up with one application, one routing application, which is running in your network. And once you want to introduce the second application, the hardware is already in place. So this becomes just another software function or another software-driven exercise of launching new services. This is why we call this a multi-service platform. In a way, or actually in every way, this is how clouds are being operated. So when we're saying we're building networks like cloud, this is what it means, essentially.
Yeah, there's lots of containerized applications or services running on this, the DriveNets, I guess, network operating system. Are those services that are part of DriveNets, or is that something that their service providers are building themselves and deploying on the platform?
The answer is yes. The answer is yes. It's stuff that we developed. Like I said, we started with building a router, so we had every functionality to do with routing, which has been developed in-house. This is mainly the types of services that we are launching in-house from DriveNets as an application, which has been provided by us. And then third-party applications, I gave the examples of analytics, a firewall, which can be coming from an expert firewall company and just be mounted onto the network cloud. And obviously, like you just said, the service providers themselves, as they want to differentiate themselves from their competition, can also develop dedicated services and mount them on the network cloud. And this is something which is still in the works with some of our prospects, but definitely under the hood, because these service providers want to protect or hide their unique or unique flavors. But this is definitely something which is within the capabilities of network cloud, of course, by definition.